Hello, I am Bhagilakshmi, Department of Mathematics, SNS College of Technology. Today we are going to discuss about the matrix eigenvalue problem. In this symmetric matrices with non-repeated eigenvalues we are going to discuss. So our first question is find the eigenvalues and eigenvectors of the matrix. The given matrix is 7, minus 2, 0 and minus 2, 6, minus 2, 0, minus 2, 5. So how to check this matrix is symmetric? First take the first row and write it as first column, and then second row as second column, and third row as third column. If these two are equal, then it is called a symmetric matrix. So here we got the symmetric matrix, and then we move on to the from this matrix. Next we can calculate the characteristic equation. The characteristic equation, lambda cube, general term for the characteristic equation is lambda cube minus c1 lambda square plus c2 minus c2 lambda minus c3 equal to 0. And then from here c1, c2, c3 are constants. So now we can calculate the c1. c1 is the sum of the main diagonal elements. So here the sum main diagonal elements are 7, 6 and 5. So adding these three values we got the answer as 18. And then so next to calculate the C2, just a minute. So calculating C2, the formula is sum of the minor of the main diagonal elements. So our first main diagonal is 7. So omit this row and column and you will get the remaining 4 values. Take these 4 values here and cross multiplying this value and you will get the answer. Likewise, remaining next element is next diagonal element is 6. So omit this row and column, remaining 4 values. So 7, 0, 0, 5. Write these 4 values here and get a value of this one, and this way we can write the values. Next one is the third diagonal value is 5. So the third diagonal value 5 means you want to omit this row and column. Remaining 4 values we can write here and get a value of these 3. Okay. So now we got an answer for these 3 values. So this way we add and subtracted these values, we got a C2 value, and C3 is a determinant of A. So the given matrix we want to calculate the determinant. It is basic one, we already studied in our school itself. So the first term 7 into remaining, the omitting the rows and columns, the remaining 4 values, we got a 30 minus 4 and minus 2 is our value. So minus 2 minus into minus plus 2 and 10 minus 0, minus 10 minus 0, we got the remaining 4 values. And the third value is automatically 0. So we got the value as multiplying the value, we got the answer as 0. So conclusion for this C3 is 162. So now we got all the 3 values. Now we can substitute in this equation instead of this C1, C2 and C3. So after that we got this equation minus 18 plus 99 and minus 62. So 162 we wrote here. So after this, using the calculator we can calculate, we can in equation mode we can replace the values of, this is values of lambda cube coefficient is A and lambda squared coefficient minus 18 is B and lambda coefficient 99 is C and lambda and the constant minus 162 is D. If we substitute like this in the equation mode, we get the lambda value is 369. Always use the synthetic division manually and you will get an answer. After this, so the lambda means it's an eigenvalue. Now we got the eigenvalues. These 3 values are 3 different values. Next value we can calculate the eigenvectors. So eigenvectors, nothing, it is first general term is a minus lambda I into x equal to 0. So in conclusion of this term is the original matrix in diagonal alone, write with the minus lambda. You'll get the equivalent matrix here. So after this, you get